Okay folks, so this video is going to have a look at integration testing. So the concept of integration testing is really having a look at two separate components and seeing how they come together at one level, but it can also be looking at how one completed system comes together and works with other systems it's supposed to. So we'll touch on integration testing at a system level shortly, but for now let's just have a look at individual components. And as I said, we're taking two individual components that we would have looked at the lower level and making sure they come together and operate as we expect them to. So looking at the bottom right image, we want to make sure that we don't have a square peg in a round hole situation. So component integration testing is performed to expose defects in the interfaces and interaction between integrated components. So on the right hand side, I've got a couple of images that kind of highlights that. Looking at the bottom one first, we can see there we've got a keyboard. So having that keyboard displayed and taking input could be described as one component, and then seeing that text actually appear on the screen as a different component. So one's used for text input, another component will display the text. Do those two components operate together as per the specification? Above that, we've got a calculator app, and again we can have the idea that a number we type in and then the arithmetic operation, so for example multiplying two numbers, does that operate as expected? So the arithmetic operation and the recording of the numbers, two separate components that we can look at and see how well they actually work. System integration testing takes up a level. So quite often we have a situation where we'll have separate software systems that have to operate with each other. So if we have a new software system that has just been completed and it needs to interact with other existing systems, then that is system integration testing. One example here on the right hand side is the idea where we have one phone that sends an SMS message, a text message. So there's one software system that looks after the sending. It's a different software system with lots of different components that is designed to receive that message and display it on the screen. So we have two separate systems that need to work together to actually display the message. So component integration testing versus system integration testing. Components are the two small units of code. Remember, they can be methods, they can even just be if statements, and looking at how they work with the other components around them. System integration testing, we're looking at completed software systems and how two completed software systems can actually integrate with each other and perform as the requirement specification dictates they should. So for doing this type of testing, the sort of test basis we would look at is going to be again the requirements and design specification, particularly focusing on the parts of those documents that talk about the architecture, any sort of workflows or any sort of use cases that describe how the system should operate. Again, with that test basis, we're looking for any tests that relate to both functional and non-functional characteristics. And in terms of the sort of objects that we'll have, we could have, subsystem databases. We could be looking at tables or different procedures associated with them. We could be looking at different components in the infrastructure or interfaces as well. So lots of different test objects we can be looking at. Now, component integration testing can be done using a number of different strategies. The one we go for usually depends on the context of the system and which components of the system are ready for testing first. The one strategy that should generally be avoided is what we call the Big Bang Theory, and the idea behind it is, let's say we have 10 components in a system, is bringing all 10 components together at the same time and seeing if they work as one. Number one, the chances are they probably won't work, but the big problem with that is it can be very hard to trace the defect. If you have 10 components, which one of those 10 components has actually caused the problem with all 10? Or do you actually have problems in more than one component? It's impossible to know if you test them all at once. So we should very much take an incremental approach, which is what we're going to chat about now, and the three different ones we can do. So in this example, we have the idea of a phone. Looking at the top level here, A, that represents the home screen in this particular case. B, C, and D will represent the submenu. And then the bottom layer here, E to I, represents different applications or different functions of the phone that we might want to access. So, for example, to open app 1, I would need to start from the home screen, go through submenu B, and then click on the application that relates to E. To get into my telephone contacts, I could either go through submenu C and then into my contacts, or go through submenu D and then into my contacts. In any case, each one of these letters represents a component of the system, so a self-contained piece of functionality that we should have in theory already tested at this stage at the component level, and now we want to see how all of these components come together and work incrementally. So from a top-down approach, we would have the top-level homepage completed, and then our first test would look as well, from the homepage, can I get the submenu B? Second test, from the homepage, can I get the submenu C? And same thing for D. So we're building it up incrementally, starting from the top level and working our way down towards the applications. So once I've tested the top tier and the middle tiers, then I start working down, okay, can I get from the top tier through the middle tier and open up app 1, app 2, the contacts, the SMS, the call, and so on. So that is a top-down approach. A bottom-up approach is literally the opposite. So the idea behind this is if I have app 1 completed, well, can I get from app 1 back up to the submenu? Can I get from the contacts back up to the submenu? So we look at the backward path from all the apps, stepping backward to the submenus, and then finally can we get back into the home menu? So we have the bottom layer completed, and then we're gradually testing as we work our way up the layers. The final approach the final approach is a functional incremental strategy. So what we do is, rather than taking the entire system and working from the top down, or the entire system and working from the bottom up, we break the system down into areas of functionality, and we test them that way. So this would work quite well in agile methodologies where we're trying to push out a minimal viable product very, very quickly, and this testing type works very well for that. So in this case, we're starting from the home screen. We're making sure we can get from the home screen to the submenu, and then from the submenu to app 1 as the first thing. And once that branch is complete, we can say that's that area of functionality completed. The next set of tests, we can maybe look at adding on the app 2. So we've got this entire branch then tested and ready for release. Once that branch is done, then we repeat the same process for the central branch and then the right branch. So we're taking the different functional areas of the application and testing them in that order, rather than taking a very regimented top-down or bottom-up approach. There are some software techniques that we need to keep in mind whenever we're planning these tests. I'm only going to touch on the definitions for now, but as we get deeper into the techniques, and particularly in your programming class, you'll learn what these are in more detail and how to actually integrate them. So a driver is something that's used in bottom-up incremental design. So we have a completed method or a completed function, and I want to actually test it. So let's say we have an application that's going to add two numbers together. Usually how that's going to work is I'm going to have a nice graphical user interface. I'll have a couple of nice text boxes that let me type some numbers in. I'll have a button that lets me click add, and then I'll have another nice little text box that's going to display my answer. The problem is, in a bottom-up approach, that may not have been built yet, but we do have the code that's designed to add those two numbers together. So rather than wait until that nice graphical user interface is completed, which may take some time to build, we write a little bit of code that just calls the method, passes in the two numbers, and displays the result. So then we know that component's ready, so whenever the nice graphical interface does come along and puts it on top of it, I don't actually need to test the code bit underneath. All I need to do is test the interface between the graphical user interface and the underlying method. So those little pieces of code that help me test lower level functional areas that have been completed, they're called drivers. Stubs are the opposite. So stubs simulate or replicate the behavior expected from lower down components. So it's used in top down testing. So in the example we just looked at, what we may have is a completed home screen, we may have a completed submenu, but we don't have the actual app 1, app 2 or the contacts function completed yet. But we just have a little bit of functionality in there that allows us to test to make sure that our menu works, and that when we click on that button, yes, I know you've clicked on that app, but nothing actually happens because that functionality isn't right yet. The final one is a test harness. So we'll use the test harness in integration testing for an entire system, and it literally just comprises of both stubs and drivers as we need them to execute different tests. So that is component and system integration testing, folks. As I mentioned, we will be looking at a few of these techniques in more detail in later chapters.